Okay, guys, I'm going to start with page 2 in case you're done with page 1 from class. Let's see, page 2 over here. Let's see if you got the right answers. First one is a cylinder with a radius of 4. So to find the radius of the base down here, we're going to go pi r squared. Area equals pi r squared. That's 4 pi squared. So area equals 16 pi units squared. And then since we're looking for a volume, we take the base, which now we know, and we let it grow by the height. So it's 16 times 10. We're letting it grow height. Volume equals 160 pi units cubed. And then I'm not going to multiply by 3.14. You could figure that out. Let's see. Same thing over here. We find the bottom. And we're going to say area equals pi r squared. Area equals pi times 2 squared. Area equals 4 pi units squared. Okay, so we got 4 pi units for that base. So to find the whole thing, we take that base, which we know, and we let it grow by the height. And then since it's a cone and we're getting ripped off at the very end, we're going to divide by 3. All right, so we have the 4 pi times 7 divided by 3. All right, you figure that out. All right, over here, number 3, we have 5 pi, or we have volume equals 4/3 pi r cubed. But the r is 5, so volume equals 4/3 pi times 5 cubed. Volume equals 4/3 times 125 pi. All right, so if you want to do in your calculator 4 divided by 3, and then that times 125, and then times 3.14, that'll give you the answer. If you wanted to do like the actual answer, or the 11th grade answer, I'd put a number on the bottom and I'd multiply those. And 4 times 125 is 500. And the bottom is 3, and then pi. So that's like the 8th grade answer, or sorry, the 11th grade answer. But I could do the same thing in my calculator, 500 divided by 3, and then take the answer and multiply it by pi. For this one, pretty easy. We look for the base, and the base is pi r squared when the r is 6. So that becomes 36 pi. And now we're going to multiply by the height and let it grow up. But then we have to crush it by 3 because it's to a point, so we're getting ripped off. So it's times 3 because we're letting it grow by 3. And then we're dividing by 3 because it's to a point. So whenever you take something and multiply by 3 and divide by 3, those actually just cancel each other out. And the volume is 36 pi units cubed. But you can tell me what that is. All right, over here, volume equals 4/3 pi radius cubed. 3 times 3 times 3 is 27. Volume equals 4/3 27 pi. You can throw those in your calculator if you want to. 4 divided by 3 times 27 times pi will give you the decimal. If you're looking for the 11th grade answer, you can multiply 4/3 times 27, and it's actually 36. When you take a 3 out of the 3 and 3 out of the 27, it's 4 times 9 is 36 pi units cubed. But you can figure out the 8th grade answer. All right, over here, don't care about the 12, I care about the 6. So when I want to find the area of the top, that's just a circle, so area equals pi r squared. Area equals pi times 6 squared. Area equals 36 pi. So we have the base of our shape is 36 pi, but to find the volume, we take that base that we know now and we let it grow downwards by 7. So volume equals 36 pi times 7. You can figure that out. All right, let's see, 3 more. A cylinder and a cone are both 6 inches tall. Okay, we got a cylinder and a cone that are both 6 inches tall. Okay, their bases both have a radius of 4. Okay, so 4, 4. How much larger is the volume of the cylinder? Well, already I know it's 3 times bigger because that's just how much bigger the volume of the cylinder is, but I think they want a number that for this one, how much does 3 times bigger actually mean? How much larger is the volume of the cylinder than the cone? Okay, so for the cone, we got to find that circle on top. So area equals pi r squared. We're trying to find this little circle up there. And the radius is 4, so now that area is 16 pi units on top. Now we're going to multiply by 6 because that's the height. That's how much it's growing down. So we get 6 times 6 is 36, carry 3, 96 pi. And that means that the cone is that divided by 3. So there's the cylinder. And for a cone, we divide that by 3. So divided by 3, 96 divided by 3 is 32 pi. So this one's 96 pi, and this one's 32 pi. So if we subtract them, how much bigger is it? That is 64 pi. That's how much bigger it is. So you tell me how much that is, the 8th grade answer of that. Okay, this one's kind of tough. A cylindrical ball canister is 8 inches high with a diameter of 2. If 4 balls fit inside, each with a diameter of 2, how much empty space is there in the canister? So basically, there's this container, like a tennis ball container. And it's got a diameter of 2, so all the way across is 2. We usually don't care about all the way across, we care about halfway. But all the way across is 2. And then there's 4 balls fit perfectly in there. I'm only going to fit 3 because my drawing stinks, but imagine there was a 4th one. And they perfectly fit in there, but there's this extra room, like where I'm coloring in, that doesn't get filled up. So we got to figure out how much is in that space. So we're going to find the whole area of the cup, and we're going to take away the volume of 4 of those tennis balls, and we're going to see how much is in there. So for the whole canister, remember, we don't care that it's 2 across, we care that the radius is 1. So for the canister, the area of the circle on top is pi r squared, where the radius is 1. So it's really just 1 times 1 is 1 pi. So the top is just 1 pi. And then we're going to let that grow down by 8 because it was, oops, I hit the wrong button, because it was 8 inches tall. So times 8, the whole thing is 8 pi. The whole cup is 8 pi units cubed. That's how much is in the whole cup. So that's the whole canister. Let's find 1 ball, figure out how big it is, and take away 4 of those from the 8 to see how much leftover space there actually is. So to find a tennis ball with a diameter of 2 inches means it has a tennis ball has a radius of 1 inch. All right, so volume equals 4/3 pi r cubed. Volume equals 4/3 pi times 1 cubed because it's just 1 inch radius. So this is just 1 times 1 times 1 is 1. So this is 4/3 pi units cubed. So that's how much 1 ball is. If we multiply that by 4, because we need 4 of those balls, we get 16/3 pi units cubed. So that's how much all the tennis balls put together. That's how much space that is. So how much is that? That's 5 1/3 pi units. So can we take we can turn 8 pi over here into 24/3 pi units. I know this is confusing, but if this was 24/3 pi over here, and this is 16/3, then when we take it away, 24/3 minus 16/3 is 8/3 pi units cubed. Long problem that I will never give you. But if you followed along and you did the work, and at least part of you understood that, maybe you're in for honors math next year. Tough one. All right, finally, a plastic manufacturer is trying to create a cone with a volume of 60 pi inches cubed. So we're shooting for 60 pi inches cubed. Okay. The customer says it's trying to create a cone, must have a height of 5 inches. So when we create this cone, it must have a height of 5. Okay. What should the diameter be to get there? How big should it be all the way across? Well, I know the area of my cone. First I have to find out area equals pi r squared of the top circle. And then we have to multiply that by the height, which is going to be here 5. And then we would have to divide by 3 because it's a cone. So that's the formula for a cone. That's how we're going to try to find this. So first what I'm going to do is I'm going to say, okay, I'm going to multiply this side by 3 to get rid of the 3 on the bottom. So I'll multiply this side by 3. So 180 pi equals pi r squared times 5. Okay. I'll divide this side by 5 to get rid of the times 5. I'll divide this side by 5 to get rid of the times 5, and I get pi r squared equals 180 divided by 5, or 36 pi. Okay, I'm going to divide this side by pi to get rid of the pi. I'm going to divide this side by pi to get rid of the pi. And I get 36 equals r squared. I'm going to take the square root of those. I get r equals the square root of 6, or just 6. But they're not looking for the radius, they're looking for the diameter. So the diameter is the radius times 2, so the diameter is 12. So I need a cone that has a radius of 12. Was that hard? Yeah, ridiculously hard. I'm not going to tell you that one. But if that makes sense to you at all, maybe you're an honors math kid next year. So copy me along. I'm showing you that they're possible. We'll do a lot of easy ones today.